So here we have compound inequalities that are OR in nature. I started solving the first one, 5z plus 7 is less than 27. I used the additive inverse property to get rid of the constant, so I took away 7 on both sides. I simplified. I have 5z is less than 20, so then I used the multiplicative inverse property and I multiplied both sides by 1/5, and therefore z is all the numbers that are less than 4. So that's one of the compound inequalities. I'm going to solve the other. Now this is what we need to remember. Any time that we multiply or divide while solving an inequality, we have to switch the inequality symbol. So in order to solve this one, I am going to multiply both sides by a third, a negative third. And when I do that, I have to switch my inequality symbol. So you just switch it, you just reverse it. Anytime you multiply or divide by a negative 1/3 times a -3 gives me 1z, and a -3 times 18 is a -6. So I've solved my two inequalities, and now I'm going to graph them. And basically what this compound inequality is stating is it's saying that z can be any number that is less than 4, or it can be any number that's greater than or equal to -6. So I'm just going to quickly plot those boundary points. Let's say 4 is over here, and I know -6 is to the left of it. I'm not going to get too picky. And I'm going to graph z is less than 4. Open circle, because it does not include 4, but it includes all the numbers that are less than 4. And then the other inequality says that z is greater than or equal to -6. So if it's got that equal symbol down there, it's going to be a closed circle, and z is all the values that are equal to -6 or greater than -6. So if you look at this compound inequality, you'll notice that the solution to this compound inequality would be all numbers, because my first z is less than 4 includes every number less than 4, and my second inequality is all the numbers that are -6 or greater, and so it's everything on the number line.